Hi there, welcome back. In this picture, I'm on page 44 of your student text or your student work text. This picture is showing you the electromagnetic spectrum. And we could spend literally a whole science class on this particular subject. I am not going to do that. I just want to point out to you some of the terms and things that you have seen. And then also we're going to take a very close look in just a second at this little section. Do you see that rainbow right in there? Right there. We're going to take a look at that in particular. So the first thing though that we need to look at is what this thing is showing me. And if you notice, there are two of your vocabulary words right here. Here is the word frequency. And remember, this is how many waves pass a given point. That's this picture that we drew. So how many of those waves fit in that 1 second thing? And then here's wavelength, which is, if you recall, the distance between the two peaks of the waves. So this chart is giving me the frequency and the wavelengths for some common things that we hear about in life. The first one that I want to call your attention to is power and telephone. We all know what our electricity and telephone services are. Then you have radio waves. And I believe that one is microwaves. It should be. It's hard to read. Microwaves right there. Infrared we cannot see. And then UV, ultraviolet, those are the dangerous ones that can cause cancer and all sorts of problems. And I wanted to look in your textbook to see if I could find another picture of the spectrum. I don't believe it is in there, or I would not have looked for another version, but it could be. And sometimes different pictures will show you different things. It actually is in there. If you look on page 98, you will see a section from about here up to here of the same spectrum. So you're seeing a little bit of a different view there. But the one in the textbook goes all the way up to gamma rays. And I like the one in the textbook because it shows you the length of the waves. So generally, the higher the frequency, the more dangerous the waves are going to be. So anything on this high frequency end of the spectrum is more dangerous to us as people. Power, telephone, those are not generally dangerous, at least not in terms of radiation. So the shorter waves, which are your higher frequency waves, are more dangerous. The other thing I want to show you in this text is about scientific notation. And that's really what I was after. So let's look at this line of numbers right there. And you also see it down here. I want to show you how to read some of those. We won't do them all, but I'll show you some. 10 to the first power is 10. That's down here at power. 10 to the second power is 100. 10 to the third power is 1,000. So you see this frequency is increasing in increments or powers of 10. Here's 10 to the fourth power. So that's going to be a 1 and 1, 2, 3, 4 zeros. So remember, this is talking about frequency. We're talking about how many waves pass that given point in 1 second. This goes all the way up to 10 to the 17th power. So let me show you what that would look like. 10 to the 17th. I need 17 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I've gone one too many. So I need to back off here. Put your commas in there every 3 zeros. Mine look a little wonky because I counted them off wrong. But this is going to be, here's your units, thousands, millions, billions, trillions, quadrillion. This is 10 quadrillion. Okay, so let's look back at our spectrum. 10 to the first power is just plain old 10. So if you're talking about power in telephone, you have 10 waves that pass that frequency interval in 1 second. If you're talking about gamma rays, the dangerous ones, you have this many waves that pass in this little interval. So that tells you how fast those waves are moving. The higher the frequency, the more dangerous the wave generally. Okay, let me show you one of these. Let's just go ahead and 10 to the negative 2 and 10 to the negative 3. I'll go ahead and do 10 to the negative 4. This is something that you can see in math quite often as well. So it's good to go ahead and talk about it. If you have 10 to the negative 2, that negative sign means that you have a decimal place. So 10 to the negative 2 is going to be your decimal and 2 places to the left. So let me not do that. And that's going to get confusing. Here's 10 to the negative 2. 10 to the negative 3. 1, 2, 3. 10 to the negative 4. 1, 2, 3, 4. 10 to the negative 5. Decimal. 1, 2, 3, 4, 5. So those negative exponents give you decimal answers. This one is 10 to the negative 9. So let's do that one. You have a decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are used for very big or very small numbers. And you see those quite often in math as well. So I wanted to just touch on that. This again is called scientific notation. You will use it if you study sciences in college. You'll get very good at using scientific notation. If you don't plan to do that in college, you probably won't use this much at all. Okay, I want to zoom in and let's look on the next page at this rainbow section right there. That is a very special part of the electromagnetic spectrum, and that's called the visible light range. So again, this is giving us the spectrum on a vertical slant. Remember the low waves, these are low frequency or lower frequency, and these are those high frequencies. So the electromagnetic spectrum shows you the things we can see and the things we can't see. The human eye is able to see these wavelengths only. And this is giving you the wavelengths in nanometers. You notice that red is the longest. Red is 700. This blue is only 400. So there's quite a bit of variance between those colors. And that's what makes the color. It's the length of the wave to your eye that allows you to perceive different colors. Red will always be the longest of the colors you can see. blue will always be the shortest of the colors you can see. And really, this is called violet. It's a blue-purple mixture. I'm calling it blue. This is blue to them. So blue, indigo, and violet. And I want to give you a little mnemonic device that will help you remember the order of the colors. This red, notice, is the longest. That's why it's on top of the rainbow. And then the violet colors are in the middle, toward the center of the rainbow. So here is the mnemonic that you can remember. It's a man's name. Let me do it this way. Sorry. If you can remember the name Roy G, that would be his middle initial, and his last name is Biv. Roy G. Biv. So we have red, orange, yellow, green, blue, indigo, and violet. And I don't care where you see a rainbow in nature, the colors will always follow this pattern because of their wavelengths. Red is always the longest, so it's going to arc, it's going to bend the most in the rainbow. Violet is the shortest of those, and it will always bend the least. So that will help you understand the visible light spectrum, and also help you remember the order of the colors. Remember Roy G. Biv. Roy G. Biv. Okay, in the next video we will be looking at motion, and we will be doing some math problems, which is my favorite thing in all the world. So I will see you in the next video for some more physics.